Hi everybody, thank you for those who have joined already. We're just going to give it another 30 seconds to a minute just to allow for a couple more people to join the session, and then we'll get underway if that's all right. So hey everybody, first I'd just like to extend my thanks for all of your time today. My name is Josh Fulford and I have the pleasure of introducing today's webinar, which is all around application security for developers. Personally, I've been very privileged to have been part of this organisation now for around 2.5 years. I'll shortly be handing over to Abhijay, who is a senior consultant here with us at NotSoSecure. He's been in the industry for around about 10 years or so now, so he really truly is a subject matter expert. As always, if you have any questions at all at any point, please feel free to send them in, and we'll be really happy to answer them, certainly at the end of the webinar when we've got an interactive Q&A session. So just before I hand over, I just wanted to spend a little bit of time running you through what we do and why it can positively affect you, I guess both from an individual but also a corporate company level as well. So NotSoSecure is an ethical pen testing and training provider, or as you can see on the previous slide, put simply, we hack and we teach. We were actually also acquired by our parent company, Claranet, a couple of years ago. And in conjunction with the logo on the previous slide, we actually operate under the Claranet Cyber Security banner. And well, that's actually quite important due to the fact that it's allowed us to offer also a more managed protection on top of our testing and training portfolio as it stands at the moment. I'll probably come back to this and touch upon this just a little bit later on. But moving on to this slide here in front of you, you'll be able to see a little bit more about the traditional types of cyber services that we provide. On the left, this is all about us looking at your security posture. So how secure are your applications? How exposed is your customer data? Where would it be possible for someone to escalate privileges? As you can see there as well, what is your strategy when it comes to network security? These are all the types of questions that will be answered as a result of these services. So these services that I just mentioned there, they're not all, but just some of the tests that we can provide. And on the right-hand side is our training portfolio. As you move down the list on the right there, you get increased difficulty and complexity. And in sort of alignment to the webinar today, you can see the application for developers will sit nicely down there on the defensive side. So you probably saw a couple of slides ago, very, very briefly, that we're actually Black Hat's largest and biggest training provider. And in 2019, in front of you there is a image of the rooms that we were training in, and in these rooms we actually trained over 600 people. Sorry. Hopefully a little bit later on we can get back to these kind of numbers when we hopefully go to Vegas once again in August later on this year. So I said I'd touch a little bit on the protection side. We also offer security as a managed service for you as well. And well, what is that? Well, we simply just become an extension of your cybersecurity team. A couple of slides ago, you would have seen that some of these services are CST, so continuous security testing, managed detection and response, and also endpoint detection. And actually, these all allow you to review your real-time threats, but also mitigate them before it's too late, which will inevitably save you some money in some form. So finally, to conclude, just ever so quickly before I hand over, why us? Well, we just want to help you on your cybersecurity journey. It's actually with this a lot of free consultancy that we offer just to help you. We can offer all sorts of types of free services, such as a free attack surface appraisal from an external perspective, and also just to add with that, our trainers are actually our pen testers. So, you know, let the real world pen testers help teach you understand how to become sort of more aligned to real world threats and how a hacker might think. With this, again, probably most importantly, we teach individuals, we bridge the cybersecurity gap by showing organizations and individuals how to become more compliant and secure. Probably today's biggest threat to an organization is actually the people. Through social engineering, why would you want to spend hours trying to gain access, when you can just pretend to be someone by saying the right things at the right time? So that's pretty much all from me, but just ever so quickly, before I hand over, as you can see on the screen there, we'll touch upon this a bit later on in the webinar, but we've actually got a chance to win a place at our next Application for Developers training course. So this webinar will give you a very brief taster as to what this entails. All you need to do is just speak to one of us, one of the team, about a potential requirement, whether it be training or pen testing, or just submit a question in the chat, and you'll be in with a chance of winning a free training place. So without any further ado, I'll hand you over to Abhijay, who will take you through AppSec for developers.
Thank you so much, Joshua. Thank you so much for the introduction. A very warm welcome to each and every one of you. A very good morning, good afternoon, and good evening to each and every one of you who have logged in from different time zones. Now, before we proceed with the webinar today, let me go ahead and provide a quick introduction about myself. So, myself, Abhijay Singh, I have actually been working for NotSoSecure for the past couple of years, and I am the lead trainer for application security for developers course and the DevSecOps course. My overall experience is around 10 years pertaining to the field of information security, majorly into the area of application security, network, and the vulnerability assessments. I have been a trainer / speaker at various international and local conferences like OWASP New Zealand, Nalcon Bangalore, and InfoSec UK, etc. Now, let's start with the very first slide, wherein we want to discuss what will the delegates actually go ahead and gain from attending our application security for developers course. Now, one thing to understand is that if you go ahead and enroll to our course, you'll be able to understand how the vulnerabilities are discovered using the same tools and the techniques that are used by researchers and pen testers, and understand its implications. Now, the second thing that that you'll go ahead and understand from our training is you'll also go ahead and understand or get on the same page with the security team when you're going ahead and discussing the vulnerabilities. You will also go ahead and understand what are the different financial repercussions or the damage that can be caused by the different web application vulnerabilities, which might be affecting your web application. And last but not the least, you will also be able to go ahead and gain insight into the latest trends, latest vulnerabilities that are used by the attackers and the pen testers to actually go ahead and exploit or gain access to the web applications. Now, this is the entire two-day course that we have. This is just a small gist of the entire two-day course that we have as a part of our application security for developers training. You can go ahead and see that we have the initial topics where we go ahead and start with the basics. We go ahead and help the delegates understand the basics related to application security. We then go ahead and ensure that all the different topics of the OWASP Top 10 that are present are covered as a part of the two-day training for our application security for developers course. Now, one thing to note over here is that the entire training has actually been developed by keeping developers in mind, so that they are able to go ahead and relate the different web application security vulnerabilities, identify them, and also go ahead and mitigate them by going ahead and attending our trainings. Now, let's go ahead and discuss what we are going to look at today. So let's go ahead and discuss the agenda for today. So we'll begin with the very first question, which is why do we actually require application security? We then move on to understand what is OWASP top 10, and then we'll go ahead and do a quick comparative study to understand the differences in the different versions of the OWASP top 10 that has been released. Then we go ahead and discuss a very important question, which is what is an attack surface when it comes to a web application? And we'll go ahead and discuss the different aspects of the attack surface. Then we look at some examples of the popular bugs that are covered as a part of our web application security for developers training. We are going ahead and covering 3 specific bugs over here in the webinar today, which is XXE. We have SSRF and the deserialization vulnerabilities, which we will go ahead and discuss today. Finally, I'll go ahead and help you guys understand on what are the key takeaways from our training, how by enrolling to our application security for developers course, you will be able to go ahead and understand application security in a defensive way, and also understand how you can go ahead and mitigate those web application security vulnerabilities as well. So without further ado, let's go ahead and start with the very first topic, which is why do we actually require application security? So to explain the need of application security, I think the very best aspect is to actually take a case study. And this is a block diagram that we actually created for one of our clients when we were going ahead and pen testing their infrastructure. So the agenda was clear. It was a 5-day red team assessment that was to be performed with the only available information as the organization's name. So we did not have any other information related to the client. We just had the client's organization name, and the client wanted us to go ahead and find out what are the different assets that are present over the internet, and find out if there are any way or any method in which an attacker can actually go ahead and get inside the internal network of the client from the internet. And that would also go ahead and help them understand the effectiveness of the different layers of security that they have implemented on their internet facing applications and internet facing devices. So we initiated the penetration testing or the red teaming exercise, and during the enumeration phase, we actually found an application which was hosted on the client's infrastructure. And from the looks of the application, it looked like that the application was created for some temporary event, and they had forgotten to go ahead and decommission that application. Now, in that application, we actually went ahead and identified a blind SQL injection attack. And using this blind SQL injection, we were able to actually go ahead and execute SQL queries. Now, by going ahead and executing the SQL queries on the MS SQL 2012 Windows host, we were able to go ahead and pass on SQL injection payloads onto the Windows host and gain foothold onto that particular system. Now, we identified that the application was accessing the database as a SA user. Now, the SA user is actually a super admin user or a root equivalent user in MS SQL databases, which can be used to go ahead and perform different operations. Now, in MS SQL database, there's also a procedure called as XPCMD shell. And using this risky procedure, we can actually go ahead and execute operating system level commands. Now, sitting on the other side of the internet, sitting on a public network box, which is the NSS box, we were practically able to go ahead and pass on operating system level commands on this MS SQL host, which was hosted on a Windows 2012 server located inside the internal network of the client's infrastructure. Now, by going ahead and using the XPCMD shell procedure, we were able to go ahead and perform post-exploitation techniques. We were able to go ahead and access the information that was present on the multiple devices present within the client's infrastructure. And finally, we were able to go ahead and gain access to the client's domain controller, and we were able to go ahead and gain access as a domain administrator. So to summarize the entire assignment, using a single SQL injection, we were able to go ahead and identify a couple of misconfigurations. And using these misconfigurations, we were able to go ahead and gain access or gain domain access to that internal system or to that internal infrastructure. So the weakness identified in this entire case study was SQL injection using the SA user, which is the root equivalent user, and not following the least privilege access control mechanism, using passwords, using the same password on different systems. It was also identified. And this is where this particular case study serves as a very good example on why we actually need to go ahead and fix issues like SQL injection and why we actually require application security. Next, we go ahead and discuss about OWASP top 10, and we go ahead and discuss the comparative study of the OWASP top 10. So OWASP is basically a open source project. It's actually a very good initiative that helps not only the pen testers but also the developers by going ahead and releasing a list of top 10 attacks that are identified throughout the industry. So OWASP releases this top 10 attack list every couple of years so that the researchers, the pen testers, and the developers are aware of what are the different vulnerabilities that are present in the web applications. And that is where we have gone ahead and mapped out the different OWASP top 10 vulnerabilities that were identified in 2010. We have the OWASP top 10 in 2013, and we have the OWASP top 10 that was released in 2017. Now, over here, I want everyone to go ahead and notice something very interesting. I want everyone to have a look at the very first aspect, which is A2. In 2010, we have the second most identified vulnerability as cross-site scripting. Now, in 2013, cross-site scripting has actually moved on to the third position. And interestingly, in 2017, you will actually find that the cross-site scripting vulnerability has moved to the 7th position in the OWASP top 10 list. Now, let's go back again to the top 10 list of 2010 and let's observe cross-site request forgery. So if you go ahead and see cross-site request forgery, it's the 5th most identified vulnerability in 2010. And in 2013, it has actually moved to the 8th position. And in 2017, you will actually find that cross-site request forgery is not even the part of the OWASP top 10 list. Now, why is this, or what is the reason behind this fall in numbers for both of these vulnerabilities? So I will come back to that question in a while, in a minute. And one more thing I want everyone to observe over here is the first or the topmost attack, which is the injection attack. So in 2010, injection attacks were the topmost. In 2013, we still have injection attacks. And surprisingly enough, in 2017 as well, we have injection rated as the topmost vulnerability. Now, the reason why injection attack is still rated as the topmost vulnerability by OWASP is because there might be a case or there might be cases where the number of issues or the number of vulnerabilities identified related to injection attacks might have gone ahead and got lowered, or they might be identified in a lesser numbers. But the impact of injection attack is such that even if a single parameter within your web application, if it is vulnerable to an injection attack, it might actually go ahead and lead to the compromise of the entire web application. And that is where the risk of having an injection attack is why OWASP still goes ahead and rates this as one of the most lethal vulnerabilities that are present in the web applications. Now, let's go ahead and discuss about the cross-site scripting and the cross-site request forgery and understand why the numbers are reducing. So there are two reasons behind the reduction in the numbers. The very first reason being, today there are a lot of frameworks that actually go ahead and provide inbuilt functions and libraries to go ahead and prevent the cross-site scripting attacks by going ahead and using techniques such as output encoding and by going ahead and doing the same for CSRF as well. So for CSRF today, the frameworks actually provide you ready-made libraries and ready-made functions using which you can go ahead and generate random cross-site request forgery tokens, which can act as a prevention mechanism for cross-site request forgery attacks. The second reason for the reduction in numbers is that the browsers today are going ahead and getting much smarter, and there are different ways or there are different aspects like the HTTP security headers, right? An example such as the HSTS header or the XXX protection header. By going ahead and adding these client-side headers, the browsers are able to go ahead and reduce the impact or the severity of the vulnerabilities like cross-site scripting and cross-site request forgery. So these are the two major reasons why there is a fall in the numbers of cross-site scripting attack and cross-site request forgery attack. Now let's go ahead and discuss about what is the exact attack surface when it comes to a web application. So to understand the attack surface, it is very important to understand the different components of the HTTP request. So this is where we can actually go ahead and see the different aspects of an HTTP request. Let me go ahead and help you understand these one by one. So the very first thing that we see over here is the method. Now, if you see, method specifies how the resource is going to be accessed. Method can sometimes be also called as verbs, and there are basically 7 different methods or verbs that are present using which you can go ahead and fetch that resource. Now over here you can see that the method is mentioned as post. The other options are get, put, delete, prop find, trace, etc. You can use these methods depending on the requirements. Next, we have the resource. Now the resource will actually go ahead and specify where our particular data or where our application is present. Next, we have the host that specifies the domain of that particular website or where our resource is actually located, which is a sample of web security. Next, we have the user agent. Now the user agent is actually used to go ahead and provide details related to the client who is going ahead and accessing the resource. After that, we have the very important header, which is the cookie header. Now this is a very simple key value pair that is present, which is used to actually go ahead and identify the users uniquely who are going ahead and logging in or accessing our website, thereby going ahead and maintaining their state. Finally, we have the post data or the user supplied data that is present. Now, majority of the feedback that we actually go ahead and receive from the different pen tests that we do or from the different trainings that we do, the developers or the application owners, they actually feel that the only point or the only location where the attackers can actually go ahead and manipulate the request or make changes is the post data or the user supplied data. So everyone feels that the post data that is being sent from the client to the server, this is the only particular location where an attacker can actually go ahead and make changes. To be true, it is absolutely not. It is absolutely wrong, because when it comes to a web application security, the entire HTTP request is considered as the attack surface. Now, let me go ahead and give you an example on why we say that the entire HTTP request is to be considered as an attack surface. Now, very recently, we were actually going ahead and performing a pen test of a web application. And this web application was actually a reporting tool that was used by the client. Now, in this reporting tool, we actually found that the application was accepting user supplied input, and any malicious payload could actually be provided in the host field of that particular HTTP request. By going ahead and manipulating the host field, we were able to actually go ahead and identify a SQL injection attack, thereby going ahead and gaining access to sensitive information. Similarly, we also identified SQL injection attack in an analytical application where the user agent was actually going ahead and getting stored into the database. And by sending out the payloads, we were able to actually go ahead and gain access to the internal database by going ahead and exploiting the SQL injection attack. So that is where it is considered, or it is said that whenever you discuss web application, whenever you discuss the attack surface of a web application, always understand that entire HTTP request, be it the referrer, the cookie, the methods, the body parameters, or the URL, an attack can actually go ahead and originate from any of these places, and hence you need to go ahead and ensure that you are going ahead and performing a validation on all the different user supplied input that is coming from the client. So the remediation to all the different bugs that are present in a web application is to actually go ahead and validate the untrusted user supplied input. The thumb rule that needs to be taken, or the thumb rule when it comes to prevention of web application security vulnerabilities, is that anything that is coming as a part of the HTTP request, it needs to be validated. And if you are able to go ahead and do that, you'll be able to go ahead and prevent majority of the web application security attacks. Now, these are some examples where host header was actually used by an attacker to go ahead and identify different issues within a web application. So for a reference, we have actually gone ahead and added this slide to show that attackers actually go ahead and use the host header injection as one of the attack vectors to go ahead and cause damage within the web application. Now, let's go ahead and discuss the most popular bugs that are present within a web application. And the very first popular bug that we will be discussing is the XXC attack. So today, XML is one of the most widely used languages on the internet, which means that there are a lot of different web applications that actually go ahead and process data in XML format. Now over here, you can see that this is an example of an API which is going ahead and accepting XML data as an input, and it is going ahead and processing that XML file and spooling out the data. Now, what can go wrong in this request? What is the maximum damage that an attacker can actually go ahead and cause through this particular request? So in XML, we can actually go ahead and declare something called as an entity, which can be used as a placeholder to go ahead and store some values, and this value can then be referenced later in the XML document. So over here in the slide, you can see we are actually going ahead and declaring an entity XXC, and to this entity, we are actually going ahead and declaring the value of an internal file using the system keyword, and we are going ahead and referencing this file in &XXC. When we send this to the application, right, you can go ahead and see how the application has gone ahead and responded to this request. And by going ahead and gaining access to the ATC passwd file, we can actually go ahead and confirm that this particular web application is actually vulnerable to an XXC attack. Now, XXC attack is prevalent because XML is used in majority of the web applications that are present. Now, let's understand what more can be done with the XXC attack. So if you have a vulnerable application that is running on AWS, XXC can actually be used to go ahead and gain access to the sensitive AWS keys, or to actually go ahead and gain access to the AWS EC2 instance data or the metadata, which is 169.254, 169.254, thereby going ahead and leaking out the secret access key, the access key ID, and the token that can be used to go ahead and gain access to the AWS infrastructure. Now, sorry, let's understand one more scenario where we actually cannot go ahead and read any file on the application or the system that we are testing. Now, there is no practical way to actually go ahead and confirm uh, the vulnerability, or to go ahead and highlight the impact of an XXC attack in that particular situation. So what do we do in such scenarios where we are actually not able to read any file, or we are not able to go ahead and gain access to any sensitive information? Now, in this kind of a situation, what if we supply this particular file? Now, this is a very special file, and we actually go ahead and call this file as the billions laugh attack file. So basically what this file does is that it will actually go ahead and print the string LOL 1 billion times. Now imagine the load your server will go ahead and take to actually go ahead and process this file. And it might be safe to say that if an attacker is actually able to go ahead and send out multiple files of this particular nature, the attacker might be able to go ahead and slow down your server, or might even be able to go ahead and crash it. Hence, XXC is a very severe issue. And now let's go ahead and discuss how we can mitigate XXC attacks. So to remediate XXC, the very first thing that we need to do is to go ahead and identify if you're using, or if you're going ahead and accepting XML input anywhere within the application. The next thing that we need to check is if we are actually using any vulnerable library that is present and that is going ahead and passing the data. Now, how do you search? Now, how do you go ahead and identify? So the very important aspect of remediating XXC is you look for these XML parsers, and you do two things. First, you go ahead and disable the entity and the external entity processing, and you go ahead and disable the DTD processing. Now over here, we have also gone ahead and provided an example in ASP.NET. You can actually go ahead and disable the DTD processing by going ahead and assigning a flag which is DTD processing.prohibit. And by going ahead and providing this flag, you'll be able to go ahead and prevent XXC attacks. Now, these are some examples on how attackers were able to go ahead and use XXC attacks to go ahead and cause damage. And you can see the monetary value that the attackers were able to achieve by exploiting the XXC vulnerability. The next popular bug that we discuss is SSRF, or server-side request forgery. Now, let's understand SSRF in more detail. And to understand SSRF, first we need to understand how an application can actually be vulnerable when SSRF attack. So the application over here, you can see an example where the application is actually going ahead and accepting user input in the form of a URL or an IP address. And what the application will actually go ahead and do is that it will go ahead and load the resource from an external system, which is the external URL or the IP address that has been provided. Now, As soon as we go ahead and provide the URL, what the application will do is it will go ahead and fetch the resource, and it will go ahead and uh, parse the input that is coming of that particular image, and it will go ahead and showcase that particular image into the dashboard of that particular application. Now, this is where the server is actually going ahead and fetching the resource on behalf of the user. And this is where SSRF can actually happen. Now, instead of going ahead and fetching the URL, what if we actually go ahead and provide the input or the URL as localhost colon 8080 or localhost colon 9200, which is the default location for the Elastic search that is present within the server. Now, the application will actually go ahead and if there are no particular validations that are being done, the application will actually go ahead and process that query, and it will go ahead and load that particular resource. And these are the techniques that are actually used by attackers to go ahead and bypass the different firewall restrictions that are present using ports 80 and 443. They're actually able to go ahead and get inside the internal network of that particular server, and they are able to go ahead and identify sensitive services such as the Elasticsearch service or the Kibana service that is present by going ahead and tricking the application into going ahead and fetching the internal resources by manipulating the URL or the IP address such as localhost 9200. Now, not just the web applications that are hosted internally, but SSRF is also applicable on AWS, where attackers can go ahead and use SSRF to go ahead and fetch the AWS metadata credentials using the metadata API of 169.254, 169.254. And by going ahead and manipulating this input, we can go ahead and use the AWS metadata API to fetch the access key, the secret access key, and the token to go ahead and perform the compromise. So how do we mitigate SSRF issues? So mitigation of SSRF is very simple. First, you need to go ahead and whitelist the domains from where you actually need to go ahead and download a particular resource that is present externally. Next, you can use techniques that are provided by AWS, which is the IMDS version 2 or the Instance Metadata Service version 2. By going ahead and using these techniques, you can actually go ahead and add dependencies using which you can go ahead and fetch the metadata, thereby preventing an attacker from going ahead and gaining access to sensitive information. You can also use response filtering as a mechanism to go ahead and understand what type of a data is expected and what data is being fetched from the server. Now, this is an example of the monetary value that was awarded to the researchers for going ahead and identifying the XXC or identifying the SSRF attack. All right, so now we move on to the last popular bug, which is the deserialization or the serialization attacks. So deserialization issues are very interesting issues because it basically deals in the way the data is being communicated. So if we take an example, today, if there are two systems who want to go ahead and communicate with each other, and let's say if we have a system A and a system B with whom the communication needs to happen between both of these systems, what are the different ways in which they can actually go ahead and communicate? So they can actually go ahead and communicate first using a normal text or a JSON or an XML format. And the second way is where they can actually go ahead and send data through a serialized communication. So what exactly happens in a serialized communication is that over here you can see an example of an serialized data in Java, and you can see in case of Java there is a car object that we want to send from system A to system B, and all we need to do is package the car object, encode it maybe in base 64, and send it over the network at the receiving system B. The system B will simply go ahead and take the serialized string and pass it on to the read object function and execute the car object on the serialized string and create the object of that in the memory itself. Now, why is this technique preferred? So if you want to go ahead and send the details of the car object in JSON or XML, then system B will actually have to go ahead and parse that particular XML or JSON file, and then they'll have to convert it into the object of type car and then start using it. But in case of serialization, the system B only needs to go ahead and read only needs to go ahead and convert the serialized string, and by going ahead and passing the serialized string through the read object function, it can go ahead and process it, thereby going ahead and making it a much faster approach. But this is the tricky part. We always know that with functionality there comes some or the other security issue that is present, and this is an example of a sample serialized string that you can go ahead and see where that we have highlighted. And the best way to identify a serialized string in Java is identifying the first 3 characters, which is RO0. Now, the problem with the serialized string that we see over here is that when it reaches the read object function, by default, there is no way the receiving object can go ahead and identify which class or object needs to be deserialized. So the attacker can actually go ahead and modify the input and send out malicious payloads to go ahead and perform remote code execution. And for such cases, you can actually go ahead and use tools like Serial, which is an open source tool, which you can go ahead and use to go ahead and create malicious payloads in a serialized format, using which you can go ahead and generate the object into a series of different gadgets that can be used to reach the java.lang.runtime function, which can be used to go ahead and perform the remote code execution. Now, this is an example of deserialization or serialization attack identified in JBoss in 2017. And it was identified that even JBoss was vulnerable to going ahead and providing or going ahead and passing user supplied input directly through the read object function. Now, how do we remediate deserialization issues? So mitigating deserialization issues is not easy because, as we discussed earlier, serialization and deserialization is actually a way of communication, which means if you have to modify anything, if you want to mitigate a deserialization issue, you might have to make changes in the way the application is communicated. And that might, in cases, actually require an architecture overhaul. Apart from that, what you can do is never provide user controlled data directly to deserialized or unserialized functions like a read object, and always prefer JSON instead of serialization options because it is a much safer option that is present. And you can always go ahead and whitelist the classes that you want to deserialize. There are also automated solutions that are present, such as the Katega NotSoSecure firewall that is present that you can use as a mitigation mechanism. Now, these are some popular deserialization bugs that were identified, and if you can go ahead and see that majority of the applications that are present, like so we have JBoss, Jenkins, Symantec Endpoint Protections, Oracle WebLogic, SAPnet Weaver. All these big applications are actually have been identified to be vulnerable to deserialization attack, some or the other. So what is the takeaway? So the takeaway is to go ahead and, so if you go ahead and enroll to our application security for developers course, at the end of the training, at the end of the 2-day class, you'll be actually able to go ahead and identify web application vulnerabilities, right? And the whole idea behind the application security for developers course is to actually go ahead and weed out the application security vulnerabilities. And for that, developer education is one of the key aspects, because developers are mostly focused on functionality today, and they are not aware of the different requirements related to security. Second, you can actually go ahead and see that today there are people, or there are researchers that actually go ahead and use checklists, right? So rather than going ahead and giving checklist or going ahead and providing checklists to the developers for secure coding, what is best is to teach the developers about the application security vulnerabilities, as by going ahead and teaching them, they can actually go ahead and relate more with the vulnerabilities that are present. They'll be able to go ahead and remediate the vulnerabilities faster by relating them. Next, by going ahead and providing trainings to the developers, you'll be able to go ahead and help the developers understand the impact and the severity of the issues, and this will go ahead and help in raising the awareness related to the secure coding practices as well. Next, it is recommended that you utilize different frameworks and libraries that are secure by default, and these examples of secure frameworks and libraries are provided in our application security for developers training. Now, one key thing that we want to ensure is that it is always recommended that you go ahead and provide your developers with opportunities to upskill themselves by going ahead and providing trainings and different ways, because the attackers today, they actually do not rest. They actually go ahead and try to target your web applications without any breaks, without any vacations. And that is where upskilling is one of the most important aspects in going ahead and preventing web application security vulnerabilities. Now, this is just right. So throughout the different topics that we have in our course, we have only covered 4 different topics, which is the application security basics. We have covered the SSRF, the XXE, and the deserialization vulnerabilities in a brief or in a very small gist, right? Many things to go ahead and note about course. The very first thing that I would like to throw light on is this is more of a language or a platform agnostic course, right? So we have seen from our previous experiences that the developers were actually able to relate to vulnerabilities much better when they see things in action. And why we say that this is a platform agnostic course is because an SQL injection will remain the same, whether it is in PHP, Java, .NET, or Ruby. The developer must actually know how to identify SQL injection in the code, and that is what we teach. Next, that being said, we've actually included different code snippets from various languages in our course, and that is what we have highlighted in red, which is the CTF, right? So towards the end of our day 2 of our course, developers will play a CTF, wherein the challenge is to actually identify a list of 18 different vulnerable codes, which are real world examples of CVEs that are present. And so these are the different topics that we have that we actually go ahead and cover and over the course of 2 days of our training. Now, this is a small introduction to our second course as well, which is the DevSecOps course. So the difference between our application security for developers course and the DevSecOps course is that in the DevSecOps course, we actually go ahead and help people understand automation around application security, how you can actually go ahead and integrate security in your CI/CD platform by integrating different tools. Our entire lab of the DevSecOps is actually based on open source. All the components, all the tools that we are using is open source, and that is where we have different topics like continuous integration, continuous delivery, infrastructure as code, continuous monitoring. All of these topics, we actually go ahead and integrate the different security solutions in the CI/CD platform to go ahead and lower the risk and by identifying the security vulnerabilities at the very initial stages of the development. These are some training dates for your reference. So if you're interested in enrolling to our course, these are some upcoming dates of our trainings that we have, which is in March of 8th and 9th and 14th and 15th of March. And this is the discount code that you can use. And this is our DevSecOps course that we are going ahead and delivering in April that you can go ahead and enroll for as well. We have some upcoming webinars as well, where we'll be going ahead and speaking about advanced web hacking, advanced infrastructure hacking, and DevSecOps. So feel free to go ahead and enroll for these as well. And yeah, so we have already provided you with the discount code that you can use if you attend our any of our trainings. And that concludes the slides for our webinar. Back to you, Ryan.
Yeah, perfect. Thank you for that, Abhijay. Just speaking for myself personally, that was the first time I've ever seen that one live myself, so I found it really informative. So I'm hoping everyone else who attended felt the same way. Just quickly, we have had a couple of questions come in. So what I'll... Oh, sorry, go on. I'm sorry, I thought someone was speaking. What just to quickly pick up, we have had a couple of questions come in. So what I'll do, Abhijay, I will hand them over to you if that's okay, and see if you can answer a couple of them. The first question we've had in is, what are the prerequisites required to attend the training?
All right, so as I said, the prerequisites to attend our training. So very first is that our training is platform and language agnostic, which means the only thing that you require to attend our training is a willingness to learn. And second, we actually have all the different tools and the different techniques and the different data related to prerequisite. Will actually be providing it to you before the training so that you are set up, and all you need is a system and an internet connection to actually go ahead and enroll or to go ahead and set our training.
Thank you for that one. We have had a couple more come in as well. Let me just quickly paste it in here. The first one was, if you have made a very secure app and then left a backdoor for maintain code or set CSP unsafe in line, could all the work used to secure the app just be a waste of time?
That left a backdoor for maintain. So actually, these are actually tricky, because when we say how safe is your application, and as I mentioned already, that when it comes to attack surface, right? Attack surface can be anything, right? It can actually be a part of a header or anything that comes. And if you have actually left a backdoor for maintaining a code set, and or if you have a misconfiguration that you have made, it's very easy, because these are the things that the attackers actually go ahead and target. They are looking for such misconfiguration. If they find even one single misconfiguration, they might actually go ahead and use it and try to go ahead and gain access to sensitive information. So the answer to that is yes. Even if you have a very simple misconfiguration that is present, it can actually go ahead and cause massive damage.
Perfect. Thank you for that. We have had one last question in. So the final question of the day is there any dependency on programming language related to the training?
No, so no, there are no dependencies on programming language. As I said, SQL injection is SQL injection on different languages, be it PHP, .NET, Ruby, or Java. The whole idea is how you can go ahead and identify SQL injection is what we teach in our course.
Perfect. Again, thank you for that. So that's all the questions we've had in today. I will just quickly hand back over to Josh, who will just quickly summarise the webinar, and thank you all again.
Yeah, I'd just like to echo that, everybody. Thank you ever so much, both Abhijay, Ryan, and all of you listening, for your time this afternoon. I appreciate for a lot of you, it might be very early in the morning. For some of you, it's like myself, it's coming towards the end of the day now. Sorry. So, as I mentioned, I just really want to say a big thank you from all of us. Please feel free to get in touch following this. Many ways to do so. There's the emails, the email addresses that you've seen over the slides. We'll email all attendees a copy of the slides or the recording, so you've got a bit more information, firstly about going over the webinar itself, but also contact information as well. There's the free webinar, the free training course, for you all to attend. So yeah, without any further ado, we'll probably conclude there. But as I mentioned, we're here to help, so please feel free to get in touch, however big or small your question may be. So thank you ever so much again, and hopefully we'll see you on the upcoming webinars we've got coming up. Thank you.
Thank you all. See you all later. Bye-bye.